We have learned to be humble under the stars. We learned that the night is not empty, that the heavens are not merely decoration, they are engines, furnaces, wrecks, and laboratories. We know of black holes, compact graves of dead stars, places where gravity crushes light into silence. We know of supermassive black holes, the enormous hearts of galaxies that weigh millions, billions of suns. But sometimes the universe surprises us. Telescopes turned to the farthest reaches have found hints, brief, stubborn signs, that something stranger still may exist, objects so vast, so heavy, so ancient that our models struggle to contain them. Black holes whose mass is measured not in millions, but in tens or hundreds of billions of suns. Beasts whose scale outruns the galaxies that surround them. If such monsters exist, they break the rules we thought were fixed. They force us to ask, are our cosmological assumptions only local truths, or tentative guesses in a far stranger cosmos? How could a black hole grow larger than a galaxy? Black holes grow by feeding. Gas, dust, stars, anything that wanders too close falls in, adding its mass to the abyss. Over cosmic time, this slow feast can indeed produce supermassive black holes. But even with generous assumptions about accretion and mergers, the early universe should not have made monsters this enormous so quickly. Imagine a black hole tipping the scales at 100 billion solar masses. That's a mind-bending number, a mass greater than some entire galaxies. To grow such a thing by eating nearby matter would require more food than the primordial cosmos seems to have had. The math balks. The timeline refuses to cooperate. So we have two hard choices. Either our understanding of early structure formation is wrong, and the early universe was wildly more efficient at making monsters than we thought, or entirely different processes are responsible. Exotic formation channels. Seed black holes born large. Collapses of regions of space with properties we don't yet model. Or something else. Are these monsters older than the universe allows? When we point our most sensitive telescopes backward in time, we look into infancy. The light arriving now left its source when the universe was young, a billion years, half a billion, sometimes a few 100 million years after the Big Bang. There, in that cosmic dawn, astronomers have seen black holes that look alarmingly heavy. A newborn universe with newborn galaxies should not have the raw material or the time to assemble such titans. It's like finding skyscrapers in a city that was newly planned only last week. The paradox is blunt, early heavy black holes shouldn't exist, and yet, the data gently, insistently says they do. That raises an audacious possibility. What if they are not products of our universe's childhood? What if they are survivors, relics from an epoch that predates our own? What if the scaffolding of our cosmos carries fossils from earlier cycles, ghosts of physics no longer active in the present? Could they be relics from a previous cosmos? The idea is as poetic as it is perilous, cosmology that folds. Some theories suggest our universe may be one phase in a sequence of births and collapses. Universes come and go like bubbles. If a prior universe ended in collapse, could its extreme objects, black holes, dense knots of space-time, have persisted, been reborn, or transformed into seeds in the new expansion? Could they have survived the cataclysm, embedded as anomalies in the infant fabric of our cosmos? If so, then ultra-massive black holes would be not merely oddities but messages, archives of physics from before. Each would be a fossilized scream from a cosmos we cannot otherwise touch. It's breathtaking and unnerving. It would mean we live in a landscape that carries memory, cosmological heirlooms that bind one universe to another. The presence of such monsters would argue that the Big Bang is not an absolute beginning, but a chapter in a deeper story. Are galaxy-sized black holes the true architects of the cosmos? Our textbook image of structure formation is tidy: gas cools, stars form, stars collect into galaxies, at the center, a black hole gradually grows. But what if nature flipped the order? What if gargantuan concentrations of mass, black holes, had already been in place and their gravity sculpted matter into the galaxies we observe? Imagine deep wells of gravity in an otherwise diffuse early universe. Matter streams inward, where the wells are strongest, stars ignite and galaxies grow around them. Black holes, instead of being pets of galaxies, would be their anchors, the engine rooms around which cosmic architecture was assembled. If true, this reverses our sense of cause and effect. It transforms black holes from consequences into primary causes. Our galaxy might be a byproduct of a cosmic appetite, the visible skin of an invisible beast whose gravity shaped the stars into order. What lies inside something so vast? Black holes are horizons, boundaries beyond which are standard rules of space and time fray. The larger the black hole, the gentler the tidal forces at its event horizon. For an ultra-massive hole, one could cross the horizon without being spaghettified at once. But beyond the horizon, physics becomes speculation steeped in general relativity and quantum mystery. Could there be structure inside? Not in any human sense, but perhaps different emergent regimes of physics. Some speculative ideas propose that interior regions of black holes might be wholesome for strange, exotic phases, regions where densities, temperatures, and the topology of spacetime allow for new forms of energy, new field configurations, perhaps even nested universes. If that sounds like metaphysics, remember that our data already forces us to stretch imagination. A galaxy-sized black hole could host conditions unlike anything we can reproduce on Earth. Within its veil, time slows, causality can twist, and quantum gravitational effects dominate. To some thinkers, black holes are wombs for new cosmoses. To others, they are computational devices that process stitched information. Either way, a black hole of such scale is not just an absence, it could be an arena. Could such black holes harbor structures, energy forms, or life beyond comprehension? This crosses from physics into bold conjecture. Life, as we know it, is a chemical dance under free energy and time. Inside an event horizon, those rules mutate. Yet intelligence might find a foothold wherever information can be stored and processed. If ultra-massive black holes possess internal regions with long-lived, stable degrees of freedom, could systems arise that exploit those degrees, computationally, physically, even biologically in a sense alien to us? We can't say yes. We can't say no. But the very question forces us onto the edge of what life and habitat mean. Perhaps intelligence in the cosmos does not require starlit oceans or rocky continents. Perhaps it can bloom in the curvature of space-time, hidden behind horizons we call forbidden. Could these black holes explain dark matter or cosmic voids? Dark matter remains the universe's most stubborn riddle, inferred from motions of stars, from gravitational lensing, from the scaffolding of galaxies, yet unseen by any telescope. Could ultra-massive black holes be a part of that puzzle? If very large masses hide in the cosmic web, especially in under-examined voids, they could contribute to gravitational effects we now attribute to diffuse dark matter. Likewise, cosmic voids, vast regions nearly empty of galaxies, puzzle cosmologists. Are they truly empty, or are they theaters for hidden monsters that prey on matter, swallowing light and leaving silence? If a galaxy-sized black hole sits in a void, its influence could carve absence rather than presence, producing a void by appetite, a darkness not of space but of consumption. Again, these are conjectures, provocative, not proven. But they are precisely the sorts of questions that the discovery of an impossible object demands. Why don't they tear the universe apart? If you cram more mass into a region than a galaxy contains, doesn't gravity go berserk? Shouldn't space-time fold itself catastrophically? The universe preserves itself through balances, expansion, dark energy, pressure, and distribution. An ultra-massive black hole behaves like a heavy anchor but also as part of a cosmic equilibrium. If such objects are rare and distributed, their gross effect is local. They bend nearby structure into a new shape but do not necessarily doom the cosmos to collapse. Yet their existence would signal that our current cosmological narratives emit powerful formation channels or pre-existing structures. Maybe the laws we infer from the present-day cosmos are emergent laws, not primordial ones. Maybe large-scale anomalies are the fossil record of different physics acting in earlier epochs, now only detectable by their gravitational fingerprints. Could we ever detect one directly? We infer black holes by the light they bend and the matter they consume, accretion disks glowing in X-rays, jets punching across intergalactic space, stars flung into frantic orbits. For galaxy-sized gaps, gravitational waves, ripples in spacetime detected by instruments like LIGO and Virgo, may be the best signposts. A merger between two ultra-massive black holes would produce waves with frequencies and amplitudes unlike anything we currently catalog. Future observatories, sensitive to lower frequencies and vast baselines, could catch these signatures. JWST and future radio telescopes might map the gravitational imprint on the cosmic microwave background or the distribution of galaxies. The hunt is on, not with nets but with mathematics and patient listening to the universe's whisper. What would it mean for humanity if one were confirmed? The first detection of a black hole larger than a galaxy would be a cognitive earthquake. It would rewrite formation scenarios, demand new physics, and humble the grand narratives we've told since we first measured starlight. Scientists would scramble to reconcile models. Philosophers would puzzle about origins and inevitability. Religions, economists, politicians, all would need to digest an event that tells us the universe has deeper layers of history and capacity than we supposed. It would not be an immediate physical threat. Such beasts, if distant, are not trampling our neighborhood. But culturally, intellectually, existentially, it would be transformative. Our sense of scale would stretch. We are tiny on a new grade. Our models are local approximations of a vaster truth. And perhaps more quietly, we would learn to listen, harder, to the echoes of the cosmos. We would accept that the universe carries secrets older than our ability to conceive, and that some of its structures are messengers, paradoxical artifacts that point beyond physics into metaphysics. Or are they not monsters at all, but guardians? A more poetic twist, perhaps what seems monstrous is functional. Perhaps ultra-massive black holes play a role in cosmic stabilization, their gravity organizing matter into habitable niches. Perhaps their jets seed intergalactic media with the heavy elements that will eventually form life-bearing planets. Perhaps the paradox is not a danger sign but a hint that universe building requires extreme extremes. Without their presence, perhaps galaxies would lack the scaffolding for long-lived, complex structures. If that sounds like mythological thinking, remember that every time humanity has met a new scale, atomic, planetary, galactic, we first feared, then learned, then found new utility. We turned thunder into energy, the atom into medicine and weapons. Perhaps this is another such threshold. And so the question remains. If the universe holds black holes bigger than galaxies, things that shouldn't exist by our provisional rules, then our cosmos is stranger than we ever dared imagine. These beasts would be relics, architects, laboratories, wombs. They would force us to rewrite the origin story of everything. Stars, galaxies, even ourselves. Maybe the largest surprises are not threats but invitations. Invitations to broaden our language for the cosmos, to invent new physics, new metaphors, new humility. To learn to read the fossils of other universes, to listen to the low, patient murmur of gravity in the void. When we look up, let us not only fear the dark. Let us also wonder what ancient giants may be watching from behind those dark, impossible horizons, and what it means that the universe keeps relics of mysteries we are only beginning to hear.